Good evening. So I'm hoping I'm live. Um, just thought I just thought I'd come on and play around with some electronics. To be honest, the yeah, just see myself come on live. Scratch my head. Um, yeah, so I just thought I'd come on and play around with some electronics. I've bought a load of electronics recently, and what I want to do is start trying to use an Arduino in order to uh, connect up to loconet and sort of build some bespoke devices. Um, I'm hoping eventually to build some bespoke um, control panels that work through loconet and so integrate with iTrain and all that good stuff. And I've also noticed that the feedback devices I've been using, the basically DigiKeys have gone out of business. So DR4088s aren't being made anymore. So I'm wondering if I can just make my own. And yeah, and also DCC Concepts seem to have stopped making the accessory decoders that I was using to control my tortoise point motors. Now that doesn't worry me too much because I've got two spare. Hold on. Right, I've got two spare, so that should be all right. Let me change my position of that. But you know, why not just learn to make my own? So I've done a bit of research and I bought a few bits and bobs. Anyway, I thought I'd just start messing around with a few things. So the first thing I need to do is get a power supply. Now I've got a power bus on my layout. I've got 5 and 12 volts, minus 12 volts and 3.3 as well actually. So I could use those. However, that doesn't really work for where I'm doing the streaming. I do streaming in my study. So here we go. I've got a wall wart. I got loads of junk kicking around and this is one of the bits of things I don't know what it used to plug into, so it doesn't really matter. So the first thing I'm going to do is see if I can use this as a 5-volt supply. I'm in the UK. For those of you who aren't, in the UK we have these awesome 13 amp sockets. These are the safest electrical outlets in the world. If you don't know about those, go and look them up. Anyway, so I plug that in and let's just see what I can get from this. You can't see that, can you? Let me put that there. Right, I'll tell you what, let me change that around. There you go, you got a slightly better view. So I'll put this on DC voltage and let me just see what this thing actually puts out. That's a pretty steady 5 volts, 5.3 volts. So I think we could probably say that was 5 volts. I think that would probably work for most things. I'll unplug it. So what I want to do first of all is this barrel plug. I mean, it's probably useful for some things. Actually, it might be useful. You might be able to plug an Arduino straight into that. Anyway, I'm probably not going to do that. So let me just, first thing is I'll just chop this off. If I leave a bit of slack on the end there, then I can, whoops, I can use the barrel plug for that as well. Probably can't. Let me see if I can change this. It's hard to know. There we go. Hard to know what you can see and what you can't. There you go. So you can see that, and you're up to about there. All right. Okay. Yeah. So I've chopped this off, and that can go in the cupboard. It's useful. And let me just split these. I got to be able to strip them. What I'm going to do is see if I can put some sort of connecting pins on these. That'll make it a bit more useful. Just take a little bit off the end. There we go. Right, now some of you will know that I'm quite into DuPont connectors, and I think I've got the DuPont connector stuff here. I need this as a crimper. And who's that? John Slee. Hi, Dave. My name's not Dave, but hello, John. And I've also got these. So this is a sort of connector set. You get all sorts of different connectors on these. Yeah. Let me yeah, let me put female connectors on these because these are live. So that would be the safe thing to do, wouldn't it? So there's an art to doing this. If you want to watch a video of someone doing it really badly, go and search some of my videos, and you can see someone completely cocking it up. I've got a bit better. Let me try and show you how to do this. So I turn up with sort of the prongs sticking away from me, and I put it in the end here, and then pull it towards me, and then close up the clamp so it grips the thing in there. So that's going to hold that, and then I can just shove this in. And what I do is I turn it around, just make sure it's got a twist in it, and I put it through far enough so that I can see the wire stick through here. But of course it's not gonna. This cable's a little bit chunky. Tell you what, let me see if I can do it in a net, a slightly larger one. Never done this before. Probably need a slightly chunkier connector. But I stick this in there until I can just see it emerging on this side, which hopefully I can. And then I just squeeze it down. And that's kind of worked and kind of not worked. So it's crimped it on, but it's not got a grip on the sheathing, which it should do, but that'll probably work for now. That's that. Let me do another one. Do it in the number 2 size. So this is because there's thicker insulation on these wires. So I'll stick it in there and give it a squeeze. There we go. And yeah, that's all the same thing. Anyway, that'll work. That'll work. And what you can then do is you can put these you put them in these blocks, and there's some single blocks here, so I can hopefully shove these into here. But I think the issue, is that going far enough? Not sure. No, it doesn't. Yeah, so the issue is going to be this insulation's too thick to fit into here, which is annoying. Not quite sure how to get around that. I basically need a larger size, a larger set. Anyway, let me try and get this done, and then oh dear, I would pick things out. What else is in there? What's my name? John. I don't normally confirm what my name is on the internet. There's a whole bunch of people who know what my name is. So it's not too hard to figure out. But I never actually confirmed that anyone's got it right, I'm afraid. Right, there we go. So we stick those two on there. Oops, that falls. This isn't working at all. The end's falling off. Dear, I'll have to go and find that later. Yeah, I don't really know what to do with this. I think I've got a knife here. See, I could try and sort of trim down. Oh, and it's even. I've lost the connector. Right, this isn't working at all then. I think that's what we're saying. Try and sort of trim down the insulation just by shaving it off like this, but this obviously isn't what you're supposed to do. This is now taking a long time. I didn't want it to. So what I'm trying to do is sort of put some sort of decent connector on here that I can, yeah, it's going to make it versatile and useful. So when I need 5 volts, I can get them. Maybe that's going to work. Have another try. So grip that in there, shove the end in. See it come all the way through, which it does, and then close it up. I think that's sort of worked, but I don't know if I'll be able to get it into one of these. So it's always a bit of a challenge getting these on. Still not going to work. You have to get it a certain distance in, and then it sort of clips in. Hooks onto a bit of plastic that's sticking through. But I can't get it through. This is annoying. Well, the only other way, if I want to do it, is to solder it first, which is a bit of a ball ache, to be honest. But I've got the soldering iron. We're playing with electronics, so might as well do it. I always used to say never sort of show yourself, never solder in a YouTube video. Well, I broke that promise. Now I'm going to solder in a live stream, it's even worse. There we go. Right, let's work this out. So yeah, I think what I'm going to need. Right, just take the ends off this again. One of these is positive and one of these is negative, and it'd be useful to know which way round that is. So we'll get onto that in a moment. So yeah, this is probably going to take a while to get where I wanted to get to. I want to just quickly try a few things out. But first, struggling to get a 5-volt power supply sorted out. Never mind, it's all part of the journey. This, like I say, I've already got a power supply for my power supply for my what? I've already got a power supply for my layout. I've got a power bus goes around. Right, if I plug this in, that's live now. So if those two wires touch each other, everything's going to blow up. So let's not do that. Right. Oops. Can't quite see this, can you? Put that there so you can see. Right. So I'm just trying to work out which is positive, which is negative. And that's minus. Right. So the one with the white stripe is the positive. That wants to be red. So I'll try and use the right colours and so on. So I've got a bit of black wire here. We'll start with that. Shut up. There we go. Hi, Roger from Sweden. Interesting seeing another hobby fellow trying to work the tool. Whatever you do, don't learn anything from me about how to solder. I am not the person to teach you how to solder. Right. I think I've got a bit of MDF here. Use that workbench. Right. If anyone's got any tips, let me know. There's always a sort of better way of doing this, soldering two wires together, but I always end up just sort of giving them a good twist and slapping some solder on. And that always seems to work. Right. Where's my solder? Got a big bag of goodies on the floor next to me. I just sort of grabbed everything I could because obviously I don't want to have to go next door to get something if I've forgotten it. Right, there we go. Well, there's a bit of solder on the joint. That is the hideous joint, but a bit of heat shrink will cure most of the problems. I'm going to want to slap a bit more solder on. There we go. Pre-tin both ends. Yeah, I know. Use the solder helper. Works with solder helper. What's the solder helper? I don't think I've got a solder helper. You'll have to tell me what that is. Somewhere, did I bring out? I bought some pliers. Just sort of squash it down. You mean the flux, don't you? By solder helper, you mean flux? Yeah, I should, but I'm not going to. I've got a little bit of red wire here, I think, as well. Is that right? Same sort of length. Go on then. I'll do what I'm told. Oh, you mean like a helping hand? Yeah, I've got one of those, but it's a bit useless, to be honest, because it doesn't tighten up stiff enough. I don't know if you can see anything. Can you see this? Probably can. Yes, it's called like a third hand or something. There we go. Well, maybe that'll hold on. Maybe. Right, that's probably good enough. Right, I've got heat shrink somewhere. Got lots of different sizes of heat shrink. This will probably do. If I just heat shrink the joints, and then no one will know what a mess it actually is. I'm not sure I've got a lighter to hand. There we go. Bit of heat shrink. Yes, and you agree. Timmerson flux in it helps a lot. Yeah. Right. There's a bit of heat shrink on there. We'll try the other one as well. Almost too small, the heat shrink. It's just about going to go over. Whoops. Look at that. Just pulled all the insulation off the black wire. A whole lot. It's no good. Feed all that back in. There we go. Right, well, just to get the heat shrink going, we use the edge of the soldering iron, but I much prefer to use a flame to do this, to be honest. If for no other reason, it makes a bit of a mess of your soldering iron. I can stick a flame on it later. Right. So what are you all doing then? Was it Friday evening? Apart from watching me try to solder badly. There we go. So that should be enough on the soldering iron. Get that out of the way. Right. So now we can have another go with the DuPont connectors. one of these. And so stick it in this end. Make sure I can see at this end. So I just put it through so just so it sticks out. And then crush it. Not crush it, crimp it. There we go, and that's nice. And what's happened, hold on, which way do how do I do it so you can see it? There we go, like that. So what's happened is the connector has been, the conductor's been clamped there, and then the insulation has been clamped there. So that should stay on. And then the other one next to it, I think it's, just need to trim back the conductor a tiny bit. After a while you get used to eyeballing it. And then we'll just stick another connector on. You're naming your iTrain feedbacks and plugs. that is a difficult job, actually, coming up with a system for naming your blocks and your feedbacks. I sort of had a bit of a system, but the trouble is you change things as you go, don't you? And you need to change your system. Right. So I've now got a red wire and a black wire with the dew point connector crimped on the end. So I should now be able to shove each of them into here. You know what I might do? I might get a bigger bit of heat shrink. Put it over both the wires. I think that'll tidy everything up quite nicely. I do love just slapping on loads of heat shrink everywhere. There we go. Look at that. Look at that. Oh, that's lovely. I'll leave that, and I'll just, when I get a flame, I'll just burn the whole thing off. Right, so I should now be able to shove this in here. This will hopefully work. And then there's this sort of plastic tab on the top, and that sort of pushes in and then catches if you try and pull it out. Right, that's one. I need another one. I know I dropped one on the floor, but I can pick that up later. So I quite like this. You can just see which is the red wire and which is the black wire, but other than that, everything will be fully insulated. It's safe. There we go. That's good. Now I realised I've made a bit of a mistake. Oh, how far apart can I keep these? All right. Well, that's good. So those are my two connectors. It gives me 5 volts. Now, obviously, what I want to do is plug it into a breadboard. And I suppose what I could do is I could put 5 volts and ground along there, and maybe next to each other. So that's that makes sense. But if I want to do 5 volts at the top and ground at the bottom, it needs to spread out. I think I want it to be tidy though, so I think I'm going to do 5 volts along the top. Now, in order to connect it, can I use, those fit on nicely, don't they? I will use 2 of these board headers. If I break that out, and then can I put that in there? Does it need to go the other way around perhaps? If it goes in that way, yeah, but then it doesn't, it's not long enough. It's not long enough for this, is it? Oh, no, it's not. That's silly. Let me try and move it. Yeah, you can move the pins halfway along each of these, see? There we go. So then if I plug in red and black, two things that I didn't want to put a male connector on the end of these, because well, because it's live. It's as simple as that. Right, so now if I plug this in, and if I give myself in fact I've got this here, so I can plug this in here, and then I can test across there, so that should be 5 volts. So at this point, okay, 1, 2, no, turn this on. There we go, 5 volts. Having a break from building my own HO scale layout. Yeah. Right. So that's that. I've got power supply. So that's good. It doesn't plug in very well though, that's the problem. Never mind. Never mind. Right. So let me put my 2-point kit away. I'm sure that'll come back out again. Right. So I've got a power supply, I've got a breadboard. Now, what can I do with this? Well, let me just talk to you about what I've been up to. I have I've been on to a company called PCBWay. I've ordered a load of these. These are circuit boards. Got 10 of them. This cost me just over £4. So these are like what, 45p each. There's no components on them, fair enough. But you can put some components on, and this forms a loconet interface for an Arduino. Let me show you what that looks like, because I've got one I made earlier. It looks like this. There's just a few components. There's a voltage regulator, some resistors, there's a transistor, that amplifies the incoming signal, receive signal, and just an indicator LED over the loconet connector, and a JR12 connector, so that's where the loconet plugs in. And so the idea of this is you plug your loconet in, you plug your Arduino in here, takes 5 volts and ground, transmit and receive, and then you can then use the Arduino to read and write the loconet, which is pretty exciting. So that's sort of what I want to work my way towards. So I got a load of these boards. I'm imagining I'm going to create several thingies. Oh, I'm tired. Right. Okay, this is the schematic for the circuit. So that's good. Right. I think what I want to do is just get some black and red wire and wire up my breadboard a bit. Black wire here, so it's good. So first thing, I want to do put the 5 volts at the ground at the bottom. I like having 5 volts at the top of the breadboard and ground at the bottom of the breadboard. That makes a bit more sense. So I haven't really done much of this since I was at school. So this is just me getting back in the swing of things, of building circuits. Cheapy wire strippers. Could be better. In there, and this goes in here. Come on. Again, if anyone's got any good tips for how to make a nice neat breadboard, let me know. Right. So now I should have 5 volts at the top and ground at the bottom. Let's just check that. Let's see if I put that right. 5 at the top and ground at the bottom. And that's not connected to anything, is it? There we go. I think that was sort of working. Not sure about this. might have to oh dear. So for some reason I'm not getting a good connection. Makes me wonder if I get a good connection from this. The answer may be no. Be careful doing this. Don't want to short them out. Okay, 5.3. So I think it's just it's a bit unhappy there. Or is it that I need to bridge? Oh, is it because I need to bridge the gap in the middle? There you go, 5.3. Let's stick it the other side. Right, okay, so right, more wires required. I think this is why I'm just having a little play. It's just to remind myself of all the things I learned in school. And just get myself going. Right. So if I put a little bridge across there, I want a red one as well in due course when I need it, then I should now have 5 volts at the top and ground at the bottom. There you go. 5.3. Right. That's all good. Now I did make a little circuit the other day. I had like a bridge rectifier, and I was rectifying the DCC signal, sticking it through a capacitor and then a voltage regulator. Give myself a steady 5 volts picked up from the track. So that's good. Right. What am I supposed to? I think what I want to do is get my Arduino. Well, I can't remember where I put it. Put it somewhere. Put it in this bag. What I have got here. These are quite fun. Got a little digital voltmeter. So if I plug this in, hopefully it'll tell me I've got 5 volts. Let's have a look. Look at that. Look at that. 5.3. Can you see that? Maybe not. It's a bit glary, isn't it? Anyway, that says That says 5.3. 5.2. Oh, it's all over the place. Anyway, that's fun. Imagine what you can get from China for not very much money. Right. Now I'll tell you what the first experiment I wanted to do actually, and that is to see if you can drive a tortoise point motor with 5 volts. And I will explain why in a moment. But let me just go and get a tortoise point motor. Oh. Right, here we go. So the reason I want to know if you can drive a tortoise point motor with 5 volts is that I found some extremely cheap motor drivers. Now, from what I understand it, a motor driver is just like an H-bridge circuit, and it just enables, using a sort of digital control, digital 5 volts, it enables you to test, to switch a larger circuit, a larger current, and in particular sort of on and off. So it works for like driving motors with pulse width modulation, and it's also the key circuit that's used in a DCC booster, because we've just taken the DCC signal, on off, on off, on off, and you want to be able to shove sort of 14 volts through it. Anyway, so there's some very cheap H-bridge circuits, but they can switch sort of, or they take somewhere between like 3 volts and 10 volts. Well, 10 volts would probably be fine, but I don't have 10 volts knocking around. I've got 12 volts. So if I plug it into 12 volts, perhaps I'll break it. But I do have 5 volts. If 5 volts would, if the tortoise point motor would be happy with 5 volts, then I can use it to make my own accessory decoders. So there we go. Can you see that? Well, it is moving, but very slowly. Now maybe that doesn't matter. Maybe I don't mind if my points go really slowly, but it is a bit of a bore. I mean, I know iTrain does one at a time. So if they go that slowly, let me try it again the other way. 1, 2, 3, 4, 5, 6. So that's taking 6 seconds to switch. I think normally you give it like 2 seconds to switch, don't you? Yeah. Ready? Now it's not working at all. Why is it not working at all? 1, 2, 3, 4, 5, 6. Hello, Heritage Line. How you doing? So that's disappointing, really. I was hoping that would switch quicker. This is a tortoise motor I've opened up. I know that it voids the warranty, but the warranty involves sending these things back to America, so that's a bit pointless. Right, so I'm not sure about that. Do I want point motors that take 6 seconds to change? Possibly not. Possibly not. Okay. Now I really want to find my Arduino. What I was thinking I could do is plug in the Arduino and then just try and write a bit of code. That's probably not going to work, is it? That's probably not a very good idea. Let me build a little circuit. I've got here. This is quite funky. So I don't really have any. You go. Why not use a 12 volt? Knock it down the regular buck converter to 9. Yeah, but the point is I've got, then I've got to have a 9 volt bus going all over my layout. I mean, yeah, sure, I can get any voltage I want. But if I'm going to do my own DCC accessory decoders, I want to sort of keep it simple, and I don't want wires going everywhere. So that's the trouble. I don't want to be distributing 5 volts, 9 volts, or 10 volts, and 12 volts. And I'm pretty sure this will work very nicely with 12 volts. So I just have to give it 12 volts, but I've then got to have a motor driver that's happy with 12 volts. And you can get a motor driver that's happy with 12 volts. It's just bigger. Bye for now. Night night. Oh, it's Wally tomorrow, isn't it? Oh, well done. John, are you local to Wally then, or are you travelling? Right. Yeah, so I was going to show you this. So this is like just a resistor kit. Loads of different resistors. What fun. And I can never remember what the color code is for all these different things, but it makes it quite easy for you because it's got a color code on the back, and it's got several different sort of bunches of them, but they're then in order. So I think what I want to do is have some large resistors. I want to build a resistor bridge thing. So if I go for a big one, a very big one. So let me give myself, it should be 10 kilo ohms. Is that 10 kilo ohms? So 10 kilo ohms should be brown, black, orange. You can't see, but it's brown, black, orange. Okay. So if I put that from 5 volts to here, so that's 10 kilo ohms. And if I then take 100 kilo ohms, 300, let's say 330. So 330 should be what? Orange, 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 I think. Or is it orange, orange, yellow? I think that's orange, orange, yellow. Yeah. So if I then go from there to ground, and hopefully the whole world won't blow up, but I need to connect that up again so the ground goes across to there. Now, if these were lower voltage, lower resistance values, then it would push more current through and they'd sort of get hot and blow up. But I think I'm probably all right. So let me see what is the... So the voltage across the whole thing should be 5.3 because that's... There we go. And the voltage to the middle, so that's 5.1, or, you know, sort of on. Now if I create a switch by having a bit of wire that plugs in, then I've got the actual switches. Let me just give myself a bit of wire. Yeah. So if I plug that in there, now if I close the switch, right, connecting it, then obviously the voltage in the middle goes to 0. And then if I open the switch, the voltage in the middle goes to 5. Very nice. Oh, what were we all talking about? Sorry, only just arrived. What was the question? Lancaster. All right. Oh, that's quite a way to get to Worley. I never read the colour codes. I'm lazy. I just use the voltmeter. Yeah. I think we all do that. But you know. Right. So that's all good. So let me just put a green wire, plug that into somewhere else. Right. Now what'll be interesting is to know how much current's actually flowing through those resistors. If I put this on amps, milliamps, pull that out, and connect this across here. It ought to tell me what the current flow is. 2 milliamps. No. 0.1 microamps. .7 microamps. So that's not a lot of current. So I'm not blowing the world up. So that's good. Okay. Now, what to do with this? I really need the Arduino. I saw it. I saw it like half an hour ago or something. Yeah, bear with me, everyone. I'm going to wander off and look for it, and then when I come back, it'll all be gone. Never mind. Well, I'm a bit baffled. I did have it to hand. Now, part of the problem is I, I'm getting ready to move house, and I'm sort of, I've got a lot of things going on at the moment, a lot of things to sort out. A lot of boxes coming in and out of the loft, and things getting thrown away, and trips to the tip, and all of that. And there's just stuff everywhere, absolutely everywhere. Obviously, getting ready to move house is a bit of a drama when it comes to the old model railway. I've got a plan. The plan is I'm going to get myself a shipping container, move it into a container. Hopefully that will. I'm just bridging this gap. Hopefully that will give me a way of sort of being able to build a layout and not have to worry about moving house again in the future. So in my line of work, I live in like tied housing, so I don't get to live in the house that I own, or a house that I own, and so there's always a risk that I'll have to move. And I started by making the layout sort of portable, so that was a good start. But really, what I need to do is make the room portable. And if I put it in a shipping container, the idea I can do that, I just pick up the shipping container and go. Anyway, but still waffling on. I still haven't found my Arduino. What's in this bag? Oh, that's my soldering bag. I reckon it must be in this box, but I've put it somewhere else. Look at these. Playing around with electronics. I got these. These are lineman gloves. Now, I drive an electric car, and I recently bought a new battery for the electric car and fitted it myself. And the voltage on the battery is like 400 volts, and that's no joke. So when you're actually playing around with the connectors for that, you want to wear lineman gloves. These are rated up to 10 kilovolts, I think. But it's what people use when they when they climb up telegraph poles and fiddle with the wires. Because it's their job, not because they're naughty boys. Right. I think what I'm gonna have to do then is to pull stumps until I can find the Arduino. What I want to do, obviously, I'll get the Arduino and then connect it to the breadboard, and do a few basic Arduino things. Sort of get a switch to work, get an input to work, get an output to work, and then once I can do that, I want to use this to plug it into the loconet. I'm hoping once I get this going, there's all sorts of stuff I can do. So the things I want to do with an Arduino and loconet, so I want to make my own accessory decoders to drive these torch point motors. That's important to me. I also want to take one line off here. I used one of these single pole double throw switches to drive the frog on the point that's being changed, but I use the other one as a feedback. And what I'm looking to feed back is the actual position of the point, and I believe I can then feed that into iTrain. So I'm assuming iTrain can then know whether the point has actually been switched or not. And I can therefore detect whether a point motor's failed or if it's told it to switch and it hasn't. So that's good. What else do I want to do with these things? I want to find a way of doing my own block detection. But I think it's how do I build my own current sensors. But I think if I can do that, I can then do block detection on the Arduino, and that will solve the problem that DigiKeys has gone out of business. Who's this? Did you get the design for that board from? Yeah, I did, from the Luco Donatella site. I don't think that works. I've tried it. Right. Okay. What doesn't work? Because that'll save me. That'll save me trying. Are you saying that the board doesn't work, or are you saying the something I've been talking about doesn't work? Gonna get in trouble now. Right. I think I'll have to wait for you to reply. So I'm doing that, but yeah, the final thing I want to do is to build some custom control panels. You run iTrain? Do you mean? You run iTrain? Okay. I assume that's what you mean. Are you talking about the feedback on the position of the points? I'm assuming that's what you mean, but let me know. Anyway, yeah. So I want to make some custom control panels. So here we go. I want to make custom control panels. So by monitoring the loconet, the control panel should be able to know when a point is requested to change, to know when the point has changed. So I can find a way of displaying both of those on the control panel. So I know like this point is, is a change pending, but it hasn't switched over yet. So that way I can detect if it's in the wrong place. If the thing's failed, I can also have a push button control or whatever to actually change a point, and instead of changing the point, it can send the command over loconet. So therefore that would then get picked up by iTrain, and iTrain would know that the point's been changed, as well as the sending the command over the DCC bus. So that'd be good. And then I'd have a control panel, and the only thing you'd have to plug in is one loconet connector, and it would all light up and be all fancy and so on. So that's where I'm hoping to get to, but I think it needs a bit of work. That board needs other made up boards to make it run. If you want to run your layout with an Arduino, you need to go to this site. Okay, I think I have done a bit of research into some of this. I'm not looking to create my to use an Arduino to run DCC++ as a controller. That's the starting point. Yeah, which site are you talking about? Did you paste a link in? Because I expect the chat doesn't let you put a link in. You'd have to tell me which. So just tell me which site it is rather than try and give me the link. Anyway, so that's where I am. But the first step to doing this is I need to actually find the Arduino that came in the post yesterday. I've lost it, so that's all a bit stupid. Yes, all right. Anyway, look, there's been various folks in this evening. It's been great to see you all. Just nice to have a chat, and I think what I'll do, I'll come back to this a bit later. I'm a bit time poor at the moment. Well, it's not I'm time poor. I've got a lot to do. That's a different thing, isn't it? But I've got a lot to do at the moment. So I think that's why I've been doing some streams recently. I haven't got time to sort of make a proper video. But yeah, I can just do a stream and mess around, fiddle with a few things. But I've got to get ready to move house. And then once I move, www. Scallen Naslag Arduino. All right, I'll look into that. Yeah, so I've got to go to move house, and then once I've moved house, everything's going to be chaos, really, isn't it? I've got to buy a container. I got to line and insulate the container. I got to move the layout into it. I got to redesign my track plan. I've got loads to do on the layout, so that's going to keep me busy for ages. But I think I might try and do some of the work indoors, and yeah, some of this sort of stuff I can do on live streams indoors. So that's where it's going to go. Anyway, look, great to have your company, and I think I'm just going to stop the stream now. I'll talk to you another time. All right. It's all right then. Bye, Mum.